So for number 3 on your interim assessment review, you have to identify the transformation that will map this figure onto itself, meaning what would give us the exact same figure back. So usually that would either entail a rotation or a reflection across a line of symmetry. So let's test each of these answers and see if any of them give us the same figure back when we complete them. Here's a couple of reflection options in A and B. So if either of these are going to work, it would have to be a line of symmetry that we're reflecting across. So let's test this out. The first one says reflect across the line y equals -3. So make sure you read that carefully. Y equals -3. So we're going to go down to -3 on the y-axis. And remember, those y equals lines are just horizontal lines. And notice here, this actually is a line of symmetry for this object, this figure. It cuts this figure right in half. So if we complete a reflection over this line, it essentially folds it in half, and this half would map exactly onto the other half, the top half, and vice versa. So it actually does give us that pre-image back. So it would be A, and we actually got lucky we didn't have to try the other ones. But essentially what you would look for is a reflection across a line of symmetry or a rotation that would rotate it back through onto itself. So the correct answer there would be A. Now number 4 is asking if a pair of perpendicular lines are rotated, which one is true? A, that rotating perpendicular lines result in parallel lines. B, the lines remain perpendicular only if they're rotated 180 degrees. They remain perpendicular to each other only if they're rotated 360 degrees. Or rotated perpendicular lines always remain perpendicular lines. So the big thing to remember here, and just as a reminder, perpendicular lines are lines that form a right angle with each other. But if we are rotating perpendicular lines, rotation is a rigid transformation, meaning it doesn't change the shape or size of our lines. So if we rotate these, it really doesn't matter how we choose to spin them. They are still going to be perpendicular to each other because rotation is, again, what we call a rigid transformation. So it's actually going to be D. They always remain perpendicular. As long as we're rotating both of them, which we are, they always remain perpendicular to each other.